It is now time to move on to section 3.5, which talks about derivatives of trig functions. So we're throwing in some trig. What we are going to do first is we are going to calculate the derivative of sine of x. So we're going to let f of x be equal to sine of x, and let's find out what f prime of x is there. So as of right now, we don't really have a rule to do this yet, and so then I have to figure this out the long way. We have to do the whole limit as h goes to 0 of f of x plus h minus f of x over h. We've got to do that. So that's the limit as h goes to 0 of sine of x plus h minus sine of x all over h. If you recall from whichever trig class you had, so either trig or pre-cal or whatever trig class you took, we had the identity that sine of a sum, so like sine of x plus h, is equal to, I can write that as sine of x cosine of h plus cosine of x sine of h. That's a trig rule. So I'm going to use that to rewrite that first term. So that's going to be the limit as h goes to 0 of sine of x cosine of h plus cosine of x sine of h. And then I have minus sine of x all over h. Since I have sine of x over here and over there, why don't I group those together? So limit as h goes to 0 of, I have sine of x right here, so sine x cosine of h. Let's put sine right next to that, just because they have common terms. Sorry for having to write so small. That says cosine x sine of h all over h. Since both of those have a sine of x, we can factor it out. And since sine of x does not have an h, I can actually pull it outside of the limit. So that's sine of x times the limit as h goes to 0 of, I'm left with cosine of h from this term minus 1 from that term over h. And then from over here I have a cosine of x with no h. So I can pull that out front. Limit as h goes to 0, and I'm left with sine h over h. Well, the great thing about that is both of these we actually did in Chapter 2. In Chapter 2, we said this, the limit as h goes to 0 of cosine of h minus 1 over h. We said that was 0, so that's sine of x times 0, plus cosine of x times, whenever we did this in Chapter 2, we said that was equal to 1. So, simplifying this, we get 0 plus sine of x, which is just cosine of x. So the derivative of sine of x is equal to cosine of x. Now, I do not expect you to do this every time, because that would just take forever, and then you'd have to know every trig rule that there ever was. So, instead of doing this for every one of them, I did it for the sine, and so now I'm just going to tell you what the rest of them are. So, we know that the derivative of sine of x is equal to cosine of x, because that's what we just did. If I did the same thing to cosine of x and worked it out, the derivative would be equal to negative sine of x. If I did the same thing to tangent of x and worked it all out as much as I could, I would get that the derivative of tangent of x is secant squared of x. Continuing on, if I took the derivative of cosecant of x, I would get negative cosecant x cotangent x. If I did the derivative the long way of secant of x, I would get secant of x times tangent of x. And then if I did the derivative of cotangent of x, you would get negative cosecant squared of x. So like I said, you don't have to go through the long process every time, right? You don't have to do this as long as you know these. Now I know it seems a little hard because it's like, how would I ever remember these, right? Well, look at this. Whenever I add a co, I'm just adding a co to whatever I had over here, right? So sine gave me cosine, so cosine would be sine, except I'm going to change what the sine is. So this was positive, so change that over here. Same thing over here. Tangent gave me secant squared, so cotangent gave me negative cosecant squared. I just added a co. Same thing over here. Secant of x gave me secant tangent, so cosecant gave me negative cosecant cotangent. So they're kind of the same. I'm just going to add a co and then change what the sine is. So yes, you do need to know all of these like the back of your hand. So let's use these rules to find some derivatives. Let's find some derivatives. So example. We're going to let f of x be equal to 5x cubed sine of x. And I want to say find f prime of x. So what I would do whenever I saw this is I would say, okay, is there any special rule I've got to do? Well, notice this is a product. It's 5x cubed times sine of x. So this is a product, and so I want to use the product rule. Okay. So remember, by the product rule, the derivative is equal to, we do the first part, so I'm going to find the derivative of 5x to the third. Bring the 3 down, and that's 15. Drop the power down by a 1, so now it's 15x squared. So do the first part, leave that one. So 15x squared sine of x. Plus, now switch them. I'm going to leave 5x to the third, so it's going to just stay 5x to the third, and find the derivative of this part. So the derivative of sine of x, as we said, is cosine of x. So the derivative of 5x cubed sine of x is 15x squared sine plus 5x cubed cosine. Again, I know I used the product rule because I have a product. Another example. We're going to do the same thing, but this time the function's going to be cosine of x divided by 4x squared. And we're going to find f prime of x. So for this one, I would look here and see this is a quotient. So I want to use the quotient rule. Remember, I said a trick on that is I do low d high, high d low over low squared. So I start with the low, which means I'm just going to write down what the denominator is. So 4x squared times the derivative of the top part. That's the d high, right? So the derivative of cosine is negative sine. So I can put the minus sign out front and make it sine of x. And then minus high d low. So leave the numerator, so cosine of x, times the derivative of the denominator. Bring my 2 down and we get 8. X, because 2 minus 1 is a 1, and so that's x to the first. All over low squared, so the denominator squared. Like I said, you do not have to reduce this. You don't have to try to rewrite this a certain way. You can just leave it like this, and that is completely fine. So again, how I do this, it's low d high minus high d low over low squared. We did that in section 3.3. If you need to, go back and watch that over the derivative rules. I also want to do an example from something we did in section 3.4, but I want to use trig. So, example, a particle moves along a coordinate axis and its position at any time t is s of t equals 2 sine of t minus t, where t is between 0 and 2 pi. At what time is the particle at rest? So remember we said at rest. If you ever see the words at rest, that means velocity is equal to 0. So I first have to find what v of t is. Remember v of t we said was s prime. So find the derivative of this. The derivative of 2 sine would be 2 cosine because the derivative of sine is cosine. The derivative of negative t is negative 1. And so I need to set that equal to 0 and solve it for t. To solve this for t, just add 1 on both sides. 2 cosine of t is equal to 1. Divide by 2. Cosine of t is equal to 1/2. So what I need to do now is I need to look and see when is cosine equal to 1/2. So you can do that on a unit circle. So on a unit circle right here, remember cosine is the value for the x. So I'm going to look at every x and see where I have 1/2. So I look, there's x equals the 1/2 right there. And that happens at pi over 3. So t equals pi over 3. And then let's see if it happens anywhere else until I get to 2 pi. Negative 1/2, so that's no good. Negative 1/2, so no good. There it is. It also happens at 5 pi over 3. So there we have it. It is at rest at pi over 3 and 5 pi over 3. Let's do some more examples of finding derivatives and ways to use them. As y'all can tell, I use these for a lot of things, and so sometimes you might see some math on here we didn't do in this class, but that's okay because I use these for all of mine. Anyway, so if you ever see something like, I don't think we covered that, probably did not. Okay, example. Let f of x be equal to 2 tangent x minus 3 cotangent of x. And I want you to find the derivative of that. So as we said from our list of trig derivatives that I said you need to know, the derivative of tangent is secant squared, and the derivative of cotangent is negative cosecant squared. So this actually isn't too bad because I can just do 2 times the derivative of tangent, which is secant squared, so 2 secant squared, and then negative 3 times the derivative of cotangent. Well, the derivative of cotangent is negative cosecant squared. So that becomes positive 3 cosecant squared. Again, just as long as we know what the trig rules are, we are good. Another example. Let's let f of x equal cosecant x plus x times tangent of x. And we're going to find the derivative of that. So for the first part, this isn't hard because we already know the derivative of cosecant is negative cosecant x times cotangent x. So that isn't bad. But looking at this part, x tangent x, I've got to use the product rule here because it's x times this, right? This is a product, and so I've got to use the product rule. Remember, the product rule says we're going to do the first part, so the derivative of x is equal to 1. So it's 1 times tangent x, so just tangent x, plus, and then leave this part, so leave the x, and find the derivative of this part. The derivative of tangent x is secant squared x. So for this one, I would just say be careful because if we notice right here, I've got to use the product rule. So just be careful there. Let's take this back to when we first talked about derivatives at the beginning of chapter 3, and let's find some equations of tangent lines. Or one of them. One tangent line. Example. find the equation of the line that is tangent to the function f of x equals cotangent of x at the point x equals pi over 4. So remember, on all of these, what I need is I need my slope and I need a point, right? Well, to get a point, that isn't hard because I just plug it in, right? So f of pi over 4, that's cotangent of pi over 4. Remember, cotangent is cosine over sine. So cosine of pi over 4 over sine of pi over 4. So bring back the units, circle over here. Cosine of pi over 4 is square root of 2 over 2, and sine is the same thing. So cosine is square root of 2 over 2. Sine is also square root of 2 over 2. So cotangent of pi over 4 is equal to 1. So because of that, I know the point pi over 4, 1. That's a point. Now I need slope. Remember, we said slope is the derivative at my point, right? So it's the derivative at pi over 4. So first I have to find what the derivative is. F prime of x here, the derivative of cotangent is negative cosecant squared. So I have to do negative cosecant squared of pi over 4. Well, all that really is just cosecant of pi over 4 squared. So I've got to find out what cosecant of pi over 4 is. Remember, cosecant is 1 over sine. Sine of pi over 4 is the square root of 2 over 2. So I've got to do 1 over that. So 2 over the square root of 2. I just wrote it down so I wouldn't forget. 2 over square root of 2 squared. 2 over the square root of 2 squared. 2 squared is 4 over square root of 2 squared, which is 2. 4 over 2 is 2, so my slope is negative 2. So my slope is equal to negative 2, and I know the point pi over 4 and 1. So I can put it in point slope form. Remember, point slope is y minus the y that I know. So y minus 1 equals my slope, which is negative 2, times x minus the x I know, so pi over 4. So solve that for the y by just distributing the negative 2. So y minus 1 equals negative 2x. Negative 2 times negative pi over 4 is positive pi over 4. And then just add 1, or pi over 2, apologies. Add 1, y equals negative 2x. If I had to do pi over 2 plus 1, that's pi over 2 plus 2 over 2, which is pi plus 2 over 4. And there it is. All right, so that is the end of trig derivatives. Please let me know if any part of that does not make sense.